Hello and welcome back to Pre-Calc. This is a video over Unit 8, Section 4, and we're going to be graphing tangent and cotangent functions in this video. Okay, so we're going to develop how we get the points on a graph and analyze the key features of these types of graphs, okay, and some translations and such as. Okay, so let's talk about a tangent function. And what I want to do, when I'm looking at these, okay, I'm going to look at this part of the unit circle, okay? And let's make some of our points here in quadrant 1. This is the point 1 comma 0. This is the point square root of 3 over 2 comma 1/2. This is the point root 2 over 2 comma root 2 over 2. This one is 1/2 square root of 3 over 2. And this is the point 0, 1. Okay. And this is at pi over 6, pi over 4, pi over 3, and then pi over 2. Now what we do here, and let's just remember what the tangent function is. The tangent function is, tangent of theta is equal to y over x. Okay, we can also say sine over cosine, but for our purposes here, we'll just use y over x. And when I look at this, okay, we've already got the table here, all right? But if I look at tangent of 0, okay, my angle is 0, I'm taking 0 divided by 1, which is what gives me 0, okay? Tangent of pi over 4 is going to give us square root of 2 over 2 divided by square root of 2 over 2, which gives us 1, okay? And then I want to look at tangent of pi over 2, which means I'm taking 1 divided by 0. And remember, if we take 1 divided by 0, that's going to be an undefined value, okay? So that's how we get that, all right? But what I want to do is work backwards and go on to the negative values, okay? And so let's look at a few of these. Let's look at these values here. This is tangent of negative pi over 6 going the opposite way. Negative pi over 4, negative pi over 3, negative pi over 2. Okay? And these are the same points that we have. This is going to be root 2 over 2, comma, negative root 2 over 2 at negative pi over 4. Negative pi over 2, that's going to be the point 0, comma, negative 1. Okay, at negative pi over 6, that's going to be root 3 over 2, comma, negative 1/2. And at negative pi over 3, that's 1/2, comma, negative root 3 over 2. Okay, so just so we have those points down, these are the same points on the unit circle, but notice that the y values on these points are negative. Okay, so what that's going to do here, if I evaluate these points for my tangent function, is going to be that the same values here that we have, but they're going to be opposite. All right, so this is going to be negative root 3 over 2. If I evaluate tangent of negative pi over 4, that's going to be negative 1. Negative pi over 3 is going to be just negative square root of 3. And then negative pi over 2 is going to have a value that's undefined. Okay, so when we have these points here, and these are opposites, let's take a look at the graph of these. Okay, so let's graph them down here. The first point that I've got on my graph is the point 0, 0. So I'm going to plot that here. Okay, at pi over 4, I've got a value of 1. At negative pi over 4, I've got a value of negative 1. Okay. And at pi over 3, I've got the square root of 3, so maybe that's the point right about here. And at negative pi over 3, I've got negative square root of 3, which is right about here. And what happens is because at pi over 2 we're undefined, okay, that means that I have an asymptote at pi over 2. Same thing at negative pi over 2, that value is undefined as well. So I'm going to put an asymptote here. So if I'm drawing my graph, what we have is we have this graph that looks like this, okay? And that's similar to what we had when we had the secant function and the cosecant function, okay? But what we realize here is that our function is periodic at the pi over 2's, okay? And so we're going to put another asymptote at 3 pi over 2 and another asymptote at negative 3 pi over 2 on this graph. Okay, and we're going to put zeros, going to cross the x-axis at the pi's, all right? And it's going to follow that same pattern that we had before. And so that's how we, generate our graph for the tangent function. All right, and that's how we get that. All right, and so we can talk about a couple things here. Okay, we can talk about the domain of this function. Okay, and remember the domain. These asymptotes are periodic. So every time that we have, it's pi over 2 plus n times pi, where n is any integer. So let's just think about it. If n is 0, okay, let me write that up over here. If n equals 0, all right, then I've got pi over 2 plus 0 times pi. So that means that I would have an asymptote at pi over 2. If n is equal to 1, all right, I've got pi over 2 plus 1 times pi, and I'm going to put this as a 2 over 2, so we can add these together. 2 pi plus pi gives me 3 pi over a common denominator of 2, and that's where I have another asymptote is at 3 pi over 2. Okay, so that's how we generate these different asymptotes. Okay, the range is all real numbers. Now, even though that we have vertical asymptotes, okay, these values here are going to go to negative infinity, and these values here will go to positive infinity. All right, these are periodic. The distance between my asymptotes is pi. Okay, asymptotes is the same, value as my domain. And then my x-intercepts occur at n pi, where n is any integer, okay? And that's at pi, 2 pi, 3 pi, 4 pi, and so on. So that's how we get that graph, okay? But the main thing is that we want to know that we have asymptotes at pi over 2 and negative pi over 2, all right? So now let's take a look at cotangent, okay? We're going to use the same kind of things here. And let's do this. And I want you to see what happens here, okay? Between 0 and pi over 2, here's my tangent graph, okay, the points of my tangent function. Now remember, cotangent is just the reciprocal of tangent. So where we had 0 divided by 1 on tangent, I'm going to have 1 divided by 0, which is undefined for cotangent. All right, and we're just going to take the reciprocal of each of these. So 3 divided by square root of 3 is just going to become square root of 3. 1 over 1 is going to say the same thing as 1 over 1. The reciprocal of the square root of 3 is going to be square root of 3 over 3. And then when we were undefined, it's going to be 0. Okay, and so let's also look at theta values of negative pi over 6, negative pi over 4, negative pi over 3, and then negative pi over 2. Okay, if we look at the cotangent function for that, this is going to be negative square root of 3, negative 1, and then this is going to be negative square root of 3 over 3, and then this is going to be 0. All right, so let's take a look here. And let's plot these points. Now remember, at 0, we were undefined for our cotangent function. So my asymptote is going to be here on the y-axis, okay? And so, what we notice here is, as I graph these points, pi over 4, 1, because these are the easy ones to graph, and then pi over 2 is 0. Notice what happens here, okay? Now, if I graph the other side of this, okay, negative pi over 2 is 0. Negative pi over 4 was negative 1, okay? Your graph is going to go like this. And you're right, okay, we're going to have the same period of pi units. And so this graph is just going to look like this and be shifted over, okay? And that's going to be the graph of cotangent, all right? So it's a little bit different, shifted over and reversed, because that's just what the reciprocal function does. So if you look here, okay, here's our tangent graph, okay, and then here's our cotangent graph. So as long as we know those points, all right, the domain is all real numbers except for n pi, okay? It's a little bit easier to do because that's where our asymptotes are. Range is all real numbers. Period is pi. Let's write in here that our x-intercepts follow that previous rule of pi over 2 plus n pi. Okay, and that's that. All right? So that's how we generate the tangent and cotangent graphs. Okay, so on this, let's talk about vertical translations. All right, so on this one, we want to graph the function cotangent of x minus 3. Now what this is going to do is this is going to shift the graph down 3 units. Okay, so now let's go ahead and graph, all right, just our regular y equals cotangent of x, all right? So let's think about what we just had. Those were asymptotic on 0, and then pi, and 2 pi, okay, and then we had our x-intercepts were at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And these did this. All right, so here's these graphs. All right, so if we put those in first, all right, then what I'd want to do is take each of these points for cotangent of x minus 3, and the points that we know are our x-intercepts. And what we want to do is we want to move those down 3 units. Okay, the asymptotes are going to stay the same, but what's going to happen is now we're going to have graphs that have just been shifted down. And that's how we graph those. Okay, so let's take a look at the next one where we talk about our phase shifts. Okay, now what we're going to do here is this is going to translate the graph pi over 4 units to the right. Okay, so let's think about just graphing y equals our normal tangent of x. Okay, and that's asymptotic to pi over 2. Okay, so I like to put those asymptotes in first. Okay, We have zeros at pi, 0, and negative pi. All right, and our graph goes up like so. Bless you. Okay, now what I want to do is I'm going to shift everything over to the right pi over 4 units. Okay, and I'm going to do this in blue, all right? And so I'm going to move my asymptotes. Well, I'm just going to move my points over pi over 2 units to the right. Okay, and that means I'm going to move my asymptotes over pi over 4 units to the right. And it's not going to be perfect, but it'll look like a shifted graph. And let's do one here. All right, so if I just draw this graph in here, then that's what my graph is going to look like. Just shift it over to the right, pi over 4 units. Okay. All right, let's take a look at the last one on this page, how to graph changes in period. Now, I want to graph y equals tangent of x over 2. And what this is going to do, I'm going to rewrite this as y equals tangent of 1/2 times x. Okay, and so what I want to look at with my period and frequency is what this 1/2 does to the period, okay? And so let's do this. Let's write out y equals tangent of bx, okay? And for period, all right, remember our b value is what affects our period. Now what I did, even though I had tangent of x over 2, I rewrote that as 1/2 x, okay? And so my period, all right, so we use the formula for period to be, and it's just going to be, because our period for our tangent function is pi, is going to be pi over b. All right, so this is where it gets a little confusing, okay? Now what I want to do is plug in my value for b. b is equal to 1/2. So if I plug that into my formula here, I'm going to get pi divided by 1/2, which is the same thing as doing pi times 2 over 1, which is going to give us a period of 2 pi. All right. Now what we had, remember, in our regular tangent graph, let's do this. It was periodic by pi over 2. Okay, so I'm just going to draw my y equals tangent of x graph. Okay. So draw my asymptotes and put in our values here, okay? But what we want to do here is add in an asymptote, or a period of 2 pi, okay? Our period here is already at pi. So what I want to do is extend that out to 2 pi. So what I'm going to do is put asymptotes at negative pi and at pi. And I'm going to have the same value at 0, but what's going to happen is I'm going to then have a new graph that's a little bit fatter than the other one, okay? And that's how we get those graphs. All right, so let's take a look at this next problem, how to graph a vertical stretch. So we want to graph the function y equals 5 times cotangent x. Now remember, let's first graph just y equals cotangent of x, okay? And let's come in here. Our asymptotes are on the pi's. So 0, pi, 2 pi. We're over here at negative pi and negative 2 pi. Okay. We know that we're going to cross the x-axis at pi over at the pi over 2. So 3 pi over 2 pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And we have a graph that's going to look like this. And it doesn't have to be perfect. Okay, and the one point that I know that I have on this graph, and let me kind of redo this part over here. The one point that I know I have is -1 and 1 there. Okay, and that's from that first page. And what I'm doing when I have 5 times the cotangent of x, it's going to be a vertical stretch. So what I'm going to do is really, you're taking your y values and you're multiplying them by 5. So on this, you're taking your y values and multiplying by 5. Okay, so that's going to make it a vertical stretch. So we're going to come in here, and we had these points at 1 and -1, and what we're going to do is we're going to put those points back up at 5 and -5. Okay, we're still going to have, when we have a y value of 0, that's not going to change the stretch of it, but we are going to have a graph that looks like this, and it's going to be much stretched up quite a bit. All right. And it's not going to be perfect. That's what the graphing calculator does. Okay, and so we'll do the same thing here and here. Keep our points at 0. And we'll just make our graph that way. All right? Okay, let's take a look at the next one where we're going to put it all together. Okay? And so, all right, so on this, you can read through this to show you like the formula. Remember, our period is pi over b. A, the number up front, is going to make it a vertical stretch. H is going to be your horizontal shift, and K is your vertical shift. Okay, so they went through and kind of already gave us what we're doing. Okay, but we're going to, this A value, 1/2, is going to shrink it vertically. Okay, the x plus pi over 2 means we're going to do pi over 2 units to the left, and we're going to go vertical shift down. Okay, because we're dealing with cotangent, let's go in and let's just graph our cotangent graph again. And I'm going to do that in red. So I'm going to draw in my asymptotes. Put in my zeros. Put in my y. I'm going to put these values of 1 in, 1 and -1, just to kind of help us with some of these points. And the first thing I'm going to do is I'm going to do our vertical shrink of 1/2. All right, and what that's going to do, so the first thing I'm going to do is the vertical shrink, A equals 1/2. All right, and so I'm going to decrease my y values by 1/2. So I'm going to come in here and put in 1/2 for each of those. Oops. 1/2. And let's draw our graph from that. All right. And so that's just going to make it shrink. Okay. And then the next thing I want to do, and it doesn't matter what we do necessarily, but the phase shift, we're going to move all these points pi over 2 units to the left and then 2 units down. All right, and so what I'm going to do with that, the first thing I'm going to do is move all my asymptotes over pi over 2 units, okay? So let me come in here and make my new asymptotes and shift those over by pi over 2, because that should help us make sure that we're within our bounds of what we need. Okay, so we'll make those first. Now I'm going to move all these other points over 1 and then down 2. So I'm going to start with this point here, and I'm looking at my blue graph. So I'm going to move that point over pi over 2 and then down 2. And then I can plot my next point here, all right, and it's going to go up like that, all right. We'll go off the graph a little bit, but let me just show you how I'm doing that. I'm taking this point here, moving it over pi over 2, and then down 2. And then putting in my other values. So over pi over 2, down 2, boom, boom, over pi over 2, down 2, boom, boom. And so then and that's how we want to do that. Okay, so it can be a little confusing with you know, where these points are at and what we're doing, but you know, it can get a little convoluted and messy, but it's not too bad. So Desmos is your friend, remember, and that's it for this part of the video. We'll see you next time. Bye.